are presenting one pillar of a program that we are developing in LIPS HR4, and also with the help of Professor Bressler, Christian, to show you some tool that already in European XFEL we use for our training, and we are going to develop and improve. Some word about European XFEL that can be useful to understand the following. It's a big science, large facilities, 3.4 kilometers long, I would say, that is with 400 employees, 250 from DAISY, that is our most important partner and shareholder from Germany. We start from 2017. Well, the insights of the facility is that we can have atomic spatial resolution, femtosecond time resolution, so and intense X-ray pulses. This is used for structural biology, for instance. What's the topic? Very nice insights, but it's really state of art, and we have to prepare our current user, but in particular the future user, for new application, even out of the normal application of the synchrotron, to use our facility. Moreover, we have also to attract new employees in our development that, of course, are not the usual one. So the needs of a hybrid or remote training was coming before the COVID. Actually, Christian will present what he's doing, but he was, of course, engaged during the COVID, but coming before the COVID. I'm also in the research and development board of LIPS, and then since we are sensitive to this topic, then we develop a program that is in digital LIPS oriented to not only attract the collaboration between our facility and industry, so-called HR Tech, that is a system of forums and other collective intelligence tool to make this one not only our user. We are going to develop a collaborative platform for smart user, but for the reason that I said, also remote staff and hybrid training. We are worldwide facility. We have to teach to future user to use our facility in, of course, I would say Asia, but also to encourage the use of our facility, develop experiment for Africa. There is a program for this in LIPS, because we believe that the more user we cover geographically, more we have a chance to express our talent. And then with this pillar, we start to look into what our 19 facilities, 16 institutions have. And we approach this workshop with a different, I would say, perspective. I see that you prepare a presentation in particular about the format of this hybrid that is very interesting for us. We have to learn from it. But I would like to give the words to Professor Bressler, Christian. It is our academic liaison office in European XFEL, to show you a tool and how is using this tool. I think it could be complementary to the format, because we are really developing technology for training. That is another aspect. So Christian, if you can take the word.
Yeah, sure. Thanks, Antoine.
I'm sharing.
Good morning, everyone, and it's a pleasure to be here. Thanks for giving me the opportunity to talk about something we have been developing. Now I have to share screen. Let's be this one. There you go.
Okay.
Yeah. So this was born more or less as a hobby, but it has developed now into actually a serious tool. True training at real facilities, like the one you see in the photo below, is virtually non-existent. There are some exceptional examples, like the Hercules course that ILL in Grenoble pioneered long time ago, and now it's a 5-week course that brings PhD students and postdocs to the neutron and synchrotron facilities where they get hands-on experience onto a beamline. This usually doesn't happen so often at synchrotron stations, and it happens not at all at free electron lasers. And so here was an attempt to enter this business. So yeah, everything is slow, you can see. Yeah, so I will give you a brief overview, but I will get it even briefer because Antonio did most of it. The software that we developed over the past 2 years of the pandemic is aiming to let users remotely or virtually understand complex instrumentation with detectors, data, noise, all these issues. They should be able to perform a complicated experiment, I'll show you in a moment, and extract from their capabilities to actually align a beamline and perform an experiment to extract the results and interpret it. We had a few test runs, and that was so successful in the sense that they said now they see the light, so how synchrotrons and so forth work. This is the broad overview. There are large-scale facilities on this planet that have synchrotrons, but more like here free electron lasers in the foreground. Worldwide, facilities important. Beam time is sparse. You only get up to 3 to 5 days of beam time, and you have to know what you're doing. This is Hamburg, the longest FEL on this planet, and as Antonio said, one of the most, or the most intense at the moment, X-ray source with femtosecond duration. This is how we split it up. Those almost 4 kilometers stretch from the Daisy campus all the way into the fields of Schleswig-Holstein, where we have at the up left then the research lab. This is now the tunnels that are underground, how we get into get through the 3 kilometers or so. And you see actually 2 tubes that are not parallel, but they are actually intersecting an infinity. In our case, it's about 450 meters from here, from the photo. But you also see it now in the lab, in the virtual lab that we created. And if time permits, I'll give you a very short sneak preview of how it looks like. This is the experimental hall, the size of a soccer field, of a commercial soccer field. And we will zoom into the green lab. That's the experimental environment we virtualized. I'll skip that. This is how we zoom into the lab. So you see all kinds of equipment. And this is what you usually see when you do a live tour of any of these light source facilities. You see all these sarcophags of equipment all over the place, which you just shrug your shoulder and say, yeah, that's probably important. What the students and users here find out is that they're mostly empty, which is a surprise to most of them. And they can then see what happens inside live. And on the lower left, you see actually what we virtualize. And actually, it's not all we virtualize now, even more. This is what I'll skip, but this is the part where I kick in, and that's where my heart gets warm. But that's the science part, but they will actually, the students and users execute such an experiment that looks so complicated as you see right now. This is how you can see the real lab near the sample environment where the experiment happens. And when you go into the virtual lab, this is roughly the same angular view that you can get. You see hopefully similar things and recognize stuff. We open up, so you walk around, but you can open up the equipment and see what's inside. That's the important part of this entire project, that you can see what's happening. And you see it with light, with photons and recordings. So here's an example of the lens stack we have. We have lenses we can plug in and out. Then you can focus the beam nicely to a very short spot. And you don't see that up here, but there's a save button where the laser pointer is, and you can download the 2D image and analyze the data you have. You can also find out that you can do silly things like you saturate the imager, then you get this flat top thing. But if you attenuate nicely, then you can see the Gaussian profile of the beam we sent in. And if you are too impatient, like I am often, then something dramatic happens that you see here on the left. You see these black spots. You burned your scintillator screen or shot a hole through it. This happens at free-electron lasers easily because we can drill with a focus beam to 30 centimeters of stainless steel. No problem at all, within half a minute. This is also one of the other devices. It's a curved crystal for the X-ray enthusiasts. I can say it disperses the X-rays in this rainbow type of fashion. So these are moving cakes of rainbows. And you can measure then on the detector up at the back, which you don't see here, but you see here something coming in. And if you align better, then you can see the data coming in, which you can, as you see in the red circle above, can download. And then you can download a single shot and you can average them, and you see then the peculiarities of a free electron laser, namely the self-amplified spontaneous emission spectrum in this example. You can zoom into every device and take a look what the hell is going on. And what you don't see in my screenshots is that you can change the angle of view. If I am permitted, I will show you a short example of that afterwards. This is what I just dragged from the latest student reports that I got. On the left, they showed their work that they did, that they extracted from such an experiment. This is a time-resolved X-ray emission experiment with femtosecond time resolution. And on the right, you see the real data, which they are supposed to actually reproduce. So these fellows were quite lazy. They only got one of the results, and so they will have to find better. But this is what you can do without anything else. You can, it's almost like the real experiment. You're not in the control room, you're in front of your laptop. This is how the experiment that I just showed you actually looks like when it's operating. This is again a screenshot. It's kind of boring, but when you see things move, then you get the fascination. Yes, if you allow me, I will then turn it on, but right after the summary that I will give you now. So this is actually the control room, and you can go through it like in an ego shooter game and see everything happen. We have now a script developed during the pandemic for bachelor students, but we also gave it out to PhD students, and it was equally useful because these are all topics that mix chemistry with physics, with laser optics, and so everyone has something to learn in there. That's the good thing. So we implemented it as a so-called advanced lab practical experiment. It is now in the third run at the University of Hamburg, and it's still popular. It's still being chosen by the students. But we also got a grant for innovative teaching and learning, where we think this could go forward. And we did a focus course this summer for, actually that's what we're planning for bachelor master level, but we did it for PhD students, and that was not virtual, that was real. And there are advantages of everything, and we can do it either way. Yes, one can now think, and the students were enthusiastic. They wanted to have neutron beam lines, electron microscopes, other free electron laser beam lines. They said to give it all to us, and that is what one can do. We can also include more equipment, which we're doing. We already included the undulators, which we have, and one could also do the whole FEL facility eventually, and later do CERN or so, who knows. Yeah, so to summarize that part, I would just say it is a new way to enter a complex lab. It works on various levels so far. Gives you realistic environment, physically meaningful data. The noise is as good as you can set up your experiment. If you do it lousy, it's lousy. And yes, you can go more. So in short, I would say it's a flight simulator for physicists. And that's what actually I'm very proud of, meanwhile, because it always got the most positive response. I have to acknowledge my group members who worked on this, but also the spin-off company from physics department in Rostov, which we now cannot engage anymore. But that's mainly run by Sasha Guda. Where is he? Here, Alexander Guda. Is a brilliant mind that helped us. And we got support, of course, for this. And now, if time allows, I would just give you a 2-second sneak preview. Is that okay?
Suzanne.
Yes, go ahead.
Thank you very much, Suzanne, to give us the opportunity, but I think it's useful.
I have my avatar here, so let's share screen. Let's screen 1. Yeah. Now let's see what you see. Do you see something? Because I'm looking for my screen. Yes, you have it. Ah, wunderbar. Now I have to go in. Yes, it should move. Okay, you see it move, right? So this is the lab in the inspection mode. It's a little bit still images for you, but not if you have the software in your computer. Now you come into any device and you can open it up. And something magic happens, and let's see, you can see the pulses nicely. Okay, so here you see forward scattering, but if I dare allow, the sample is, you can see it here, it's actually a liquid jet, and you are shooting with the stuff from the left are the X-ray pulses from the Free-Electron laser, and on the right is a laser that is striking the sample to do this pump probe experiment. But what you also see is, it's actually very nice. I go to an angle in the back there, you see our X-ray emission spectrometer here. Let's go, yeah, that makes sense, right? Now you can roughly see it, and you see how it operates. So the rainbow cakes that you see are for a reason. It's a physics because we have blue and red X-ray light. It's not visible, but longer and shorter wavelengths. And they actually hit the detector. And now I'm looking at the wrong detector. I will look at the right detector. And this is the detector where we're measuring the spectra. And you can also see that I can see different spectra. But what I'm exceptionally proud of these programmers for is they got the geometry right. So here you can see, I have to take out the attenuators. Yeah, sometimes you know. Anyway,
it's a real time, so it's nothing prepared.
Yes.
Thank you, Christian. It's really.
But I hope you can get the picture. But yeah, this should now. There you have it. Now you see the 2-dimensional focus, line focus on the detector, and now I can move the detector a little bit backwards. You might see it move backwards to the left. That means you see it go to the left. And you see how I screw up the alignment. Isn't that brilliant? I mean, this is just a dream come true because it's all live. So you can then align the whole thing so that you can see that you get the nice line focus. And that's how things work. And there are infinite other stuff. You can go then a whole kilometer upstream. Do you see that? That was too fast, probably. And then you can look inside an undulator, and if we wait long enough, I'm not sure, there they are. You can see the ants marching in, and that's the operation of an undulator. Right now, this is only an animation, but it will turn into physics as well. And you see the blue X-ray flashes and the red wiggly electrons. Okay, I could go on for half an hour now, but I guess I would probably best stop and hope for questions. So
I think it's really amazing what Christian and his collaborator were valuing, but also amazing that he's using, as he showed, for training, and is in development. So we are also we have also to look probably for funding in the future to create other I think, features, and in particular, perhaps other platform or other facility representing. But the direction is really, I think, good for our idea.